Of course, before we talk about homework problems, let's remember what we learned. So please ask yourself, what is your takeaway really from this class? But more importantly, as I always tell you, think about what's not clear to you and how you can actually improve your knowledge about the things that are not clear to you. Only if you understand what's not clear to you, you can actually make an improvement. So please go ahead and do that. Last but not least, let's check off our final checkpoints here. So first, we of course understand or recall Newton's third law, and we know what force equilibrium is. That was definitely explained in this lecture, and we now understand where that's coming from and why we need this. Then we talked about equilibrium conditions, and that is very important to be differentiated from the equilibrium equations. And we did this, of course, in 2D. So we understand the difference for those and what they are. Likewise, we talked a lot about free body diagrams, and we can now understand every significant component, and we know how they are to be interpreted. In fact, we can definitely professionally draw them now because we know how to include all important components and aspects. So that is done too. And then, of course, we used these free body diagrams to derive our multiple equations, which we can now solve, right? So by using multiple equations with multiple unknowns, and we learned the substitution method, but really any method really works. So we can definitely solve multiple equations with multiple unknowns. And I believe that this overall goal of the lecture was to really understand how cable structures carry forces and how we can solve them. So hopefully we can check that off. And remember that we're only talking about tensile forces, so that we understand how they are transferred within a cable system. So that gets a check. And last but not least, we can definitely solve them for like real world examples. So I think we had real world pictures that we used to derive the conditions and the equations, and that concludes our final checkpoints. So I wish you good luck with that, and hopefully you can check off as many boxes as I can here. Let's talk about the homework. As you can see here, we start the homework with very basic problems, just like idealized problems, if you will. In fact, the free body diagrams are already given to you. So here you have to pretty much make sure that this particle at the origin remains in equilibrium. So you have an FA and an FB, and you have F1 acting in this direction. Angles are given here to you, so this should be solvable for really every student in the class, independent of the different variables. Let's move on to the next problem. So problem B here is also a particle problem where this particle at the origin has to remain in equilibrium, and you have to substitute your values here and find FA and angle theta such that the system remains in equilibrium. Now, it may be the case that some students have such a strange F2 relative to F3 that this problem cannot be solved, although this would be very, very unlikely. But there may be one or two students who cannot do that based on their variables. If that happens to you, then you, of course, have to show and explain why that is the case. But I believe that this, for 99% of the students, should be solvable. Let's take a look at the next one. This becomes interesting now. Here you will see a Guesset Plate, which is a very famous structural component. When we talk about trusses, you don't have to understand this here right now. But what you see is that there's one point of origin, which is the point where all the forces meet. And notice here that this is different from cables actually, because here you can also have a compression force. So notice that the 15 kilonewton here is actually pushing on the origin here, and so is the 10, whereas FB and the 5 kilonewton is actually pulling away from it. So please understand that that has an impact on your free body diagrams, in which direction you draw them, and also in, of course, solving the problems. But you have all the tricks you need to check your work. So I wish you good luck with that problem. And then here is another real world problem, if you will, where you have a boat that is attached to a bridle system, which then is anchored to F4. So there's a force of F4 acting in this cable AB because the boat is pulled away from shore, or from the anchor point, I should say. And therefore, you can calculate what the forces are in BC and BD. And please understand that this is actually a planar system. So don't get confused by this seemingly 3D picture, right? Obviously it's attached to the boat in different locations and it's like somewhere random in space. However, A, B, C, and D are all acting in the same plane. So you can definitely solve this problem. And I believe that concludes an overview of the homework and provides you with all the information that you need to solve equilibrium of particles. I wish you good luck with your homework. I'll see you in the next lecture. Stay safe.